Good evening, gentlemen. How you guys doing?
Hey, everybody. We're at the top of the hour, so I'm going to give our introduction here. Just a reminder of the ground rules here. If you can save all questions to the end, I'm going to ask some lead-in questions, and then if you guys could just use the hand raise icon, and I'll call on you. We can get started with the FAQ or question and answer response. Sorry. All right, so leading in, good evening, UNSY 603 students and anyone else really that's watching this. We have folks from both my section of the class as well as David Warden's class. I'm really thrilled to welcome you all to what is the 10th session of the UNSY Guest SME Speaker Series. I'm Dr. Brent Terwilliger, the program coordinator for the Master of Science in Unmanned Systems degree. Tonight, we're joined by Ryan Langlois, the Unmanned Systems Engineer with Torch Technologies at Eglin Air Force Base, Florida. Mr. Langlois grew up east of Dallas, Texas, where he joined the Army at age 19. He had no intention of spending any longer than necessary to receive the full GI Bill. However, 9.5 years later, 5 years of that spent in special ops, airborne, air assault, and 3 combat tours to Afghanistan, he decided to get his degree and get out of the military. As a signals intelligence or SIGINT analyst and ground collections SME, Ryan realized the future of tactical collection was moving expediently to UAS. He subsequently decided to pursue a BS in General Aeronautics with the realization, or with a minor in UAS at Embry-Riddle. He graduated Magna Cum Laude in 2016 and exited the military just months later. He also entered almost immediately into the Master of Science in Unmanned Systems program and graduated in 2018 with distinction. He was self-employed as a commercial UAS operator, and then Torch Technologies discovered him locally, offering him an engineering position on the Technical Management Advisory Services, or TMAS, contact with Air Force Research Labs Munitions Directorate at Eglin. He's currently a UAS SME specializing in UAS technology integration, flight ops, and autonomy research and development, as well as science and technology, with 15 subordinates that support multiple facets of research, including fully autonomous vehicles, biology, navigation and estimation, modeling and simulation, localization, and guidance development using exteroceptive sensing technologies. So I also want to say that I had Ryan in several of my graduate classes. He was always a phenomenal student, and he went above and beyond. He joined us in extracurricular activities where we did analysis of SUAS for a consumer report that we produced during his studies. I can't say enough about how those sort of activities, those sort of involvements, that when you see those opportunities, grab them with both hands, because you never know how that might lead to the next thing. From some of those interactions, I believe, and Ryan can speak to this, but I believe he worked with some of the other graduate students and found some really good opportunities come out of that. So with that, I'm going to turn the floor over to Ryan so he can talk to us about how he uses unmanned system technology, as well as get his personal insight and perspective concerning the evolution and growth of the technology.
Thanks, Brent, and thanks everybody for being here. Again, my name's Ryan Langlois. I'm a prior Army guy, so I don't view myself as the smartest character. A little background on Air Force Research Lab. So yes, I work for Torch Technologies, but Torch Technologies is on actually just a major services contract to Air Force Research Lab. So I am what we call a lab monkey. I work in the lab, and with that, Eglin Air Force Base's ranges are part of our lab. So we do fly our vehicles quite frequently. Being at Eglin and in the lab here, I've been here about 4 years now. I think I just hit my 4-year anniversary. I've moved up the chain pretty quickly, and a lot of that I think has to do with just kind of my personality and the way I've reached out doing different things extracurricular for Brent whenever I was in school, my military background, etc. So I highly advise these extracurricular because it pays dividends at the end. And part of that, you wind up meeting folks like Mr. David 30acre. I've met some folks, if anybody's out of the Daytona Beach campus, I've met some folks from Census Technologies. They're all Embry-Riddle grads as well, so great friends with them. There's a company out of Iowa that I'm great friends with, Nathan Eek. He runs a company called Dual RC, another Embry-Riddle grad. So take all of this, and obviously take everything I say with a grain of salt, but take your degree and the people you meet and hold on to that, because they're really going to pay dividends for you in the future. So at AFRL, at Eglin, we are RW, or the Munitions Directorate. So all we do is, big Air Force munitions development. So what does that really mean, and how does UAS play into that? So the way we look at it is, if you want to build a new cooperative or collaborative system, munition system, and you want to go test it, that munition could cost you $1 million, 10 million, who knows how much. Even upwards of, cheap munitions are still 85,000 bucks a piece, and you want to go try and test some of them on the range, you blow them up and that's $85,000 down the toilet, right? Or $1 million down the toilet. So what we do is, when we want to test these new technologies, we put them on small UAVs. And these small UAVs are 99% COTS. Everything we do is COTS. My entire job, even though I have a security clearance, my whole job is unclassified, because everything we do is COTS. So, or most everything we do is COTS. So we will fly sometimes for some sensitive programs, but generally it has nothing to do with the airframe or anything we have in it. So for different technologies that we are developing, our primary focus in my lab, which is the Multi-Domain Network Weapons Lab, is collaborative and cooperative systems. So we develop autonomy algorithms or plays, we put them onto small UAS, and we go fly them. And we test these fully autonomous plays, algorithms, swarming plays, target recognition. We do a lot of machine learning development and integration with these planes, or even some of these quads, and then go out and test them. So we have quad rotors that we have flown. We've built some in-house. We've bought some that we've integrated our stuff onto, some different exteroceptive sensing type or techniques that we've integrated to do SLAM, or simultaneous localization and mapping. Essentially, we would release upwards of 10 quad rotors in a confined underground space, GPS denied, and have them completely map in 3 dimensions, completely map and share those maps and combine those maps and totally map out an entire cavernous structure or underground subterranean structure. And then on top of that, we would add in things like automatic target recognition, where you use a machine learning algorithm to find different objects or find people. And we're doing all of this in real time on board with no pilots. So if we have 10 vehicles, we may have 1 pilot, maybe me, maybe somebody else, but generally, if it's going to hit something and crash, so be it, because we're not a munition. We are a expendable UAS asset, a research vehicle. Now, that doesn't mean that these vehicles aren't expensive, but they're not as expensive as like $1 million warhead or something, right? That the United States Air Force is going to test out on the range. But if I've got $15,000, $20,000, $25,000 into a plane, that seems very expensive, but it's really not in terms of the bigger picture, right? So the current program that we're working right now, we do fly a lot of different planes, right? So our current program right now is a swarming dual engine styrofoam. We call it a styrofoam igloo cooler, because it's literally styrofoam RC airplane that we buy from Dual RC. And then we tear out all of his guts and put in all of our own. So with that, we have, again, everything is COTS. We have a Pixhawk autopilot, which I'm sure most of you guys are familiar with. We have RFD 900 radios, which I'm sure most of you guys are familiar with. Now ours are unlocked, but that doesn't mean a whole lot for you. We just don't, because we're DoD, we don't have to deal with FCC compliance, right? We have NVIDIA onboard processors. So the Jetson family of computers, I don't know if anyone's ever seen those before, but they offer a wonderful line of onboard processing, lots of CUDA cores if you have any kind of vision-based autonomy that you're dealing with. So, and then everything else is, you know, Tiger motor, right? So the motors come from Tiger motor, or the ESCs, the speed controllers are coming from Hobby Wing, right? So everything we do is all COTS. Our power supplies are from Mach or Mach Electronics. They're out of Germany, or mostly built in China, but that's one of the most popular power supplies for all RC airplanes in the country, right? So everybody uses Mach. What else do we have on there? We do have some other, I don't want to call them proprietary systems, but we have some other systems that we've worked with third-party organizations. For example, even though we have geofencing on the autopilot, we are required by range safety to have an entirely independent geofence system on that plane. So we go through a company called Balloon Tech. They build a UAS bounder, but they actually use it for hot air balloons, not hot air balloons, but weather balloons, right? So, and that's how they are able to control their boundaries for their weather balloons. So we worked with them, advanced their board, and nothing crazy. It's just a GPS with servo commands that go through it. And when it breaks the pre-programmed GPS boundary, it will aero terminate the plane and prevent us from flying too far off range. So, again, totally independent system. It's totally open source. It's COTS. We can send that out to anybody, right? So anybody can use that from them. And the only other system that we use that I would still consider COTS, but maybe not totally COTS, is what's called it's a total mesh radio from Persistent Systems. It's called their MPU-5. That is probably the most expensive piece on our entire plane. It is a 100% mesh capable radio. It is only sold to US DoD and first responders. So that's the only component that you really can't use overseas, if you will, or share any information on. So, but everything else on that plane, the servos, even they're cheap UAS RC airplane, American made. I would almost say garbage, because we look at it as a expendable asset, right? So again, what we're doing though is not testing the plane. Even though we actually test the plane, the whole goal is not to test the plane, it's to test the algorithms. What we're making these planes do is swarm in different configurations, identify and attack targets at the end of a range. Everything we do is beyond visible line of sight. It's kind of hard to test any form of algorithms for a munition if you're staying within, what, a kilometer that you can actually see this little plane. So even though our pilots have like eagle vision, I swear, some of these guys can see this thing like 5 miles out, right? So nonetheless, we always fly beyond visible. So I know that there's a lot of challenges in the FAA world, in the commercial world, with BV loss. And, you know, when I was in school, that was a big front, right? How do you combat the beyond visible line of sight? And it still is now, but to my knowledge, the FAA now has several beyond visible line of sight testing facilities across the country, et cetera, right? So, but those are all things that really have come from folks like us. We've already tested it. We've already done it, right? So we have closed airspace. We can do almost whatever we want. If I want to go up to 10,000 feet and do an 80-degree bank angle dive at 300 miles per hour, I can do that, right? So, I don't have to get that approved or some waiver from the FAA because I'm in restricted airspace, which brings me to another aircraft that we have, another platform that we have. We fly BVM jet. So you can look up BVM. Again, everything's unclassified. BVM was Bob Violet Models. Bob Violet actually passed away about 2 years ago, and all those planes, that company was sold to somebody else, but we still work with them. It's basically a 1/5 scale F-15. It has a P60 JetCat turbine in it that's kerosene powered. and it will do about 260 knots in straight and level flight at about 20 feet off the deck. So if you've ever wondered what a mini jet sounds like from about 30 yards away at 260 knots, it's pretty impressive. But again, so what do we need to do with these crazy fast movers, right? Well, we're munitions. We're supposed to be testing munitions. When you're flying an RC airplane, it's one thing to tell somebody, hey, look at all this great stuff these 100 munitions will do, these 100 planes will do at 30 meters per second, right? So they're doing 70 miles per hour. Well, rockets, munitions, you know, don't go 70 miles an hour. They're breaking the sound barrier. Well, we can't quite do that, but we can at least do things a little more in real time, closer to, you know, 1/6 Mach or even close to half Mach at some point. So AFRL, this takes me back to AFRL. I work in a networking branch, and there's other branches. So to include the seeker branch. So seeker branch came to us and they developed missile seekers. Seeker branch came to us and said, every time we put this seeker on a $1 million warhead, it crashes, it explodes, and we don't get our data. So how do we get it back? And we said, okay, well, we'll take our jet, we'll cut the nose off of it, we'll put an actual missile seeker on it, we'll take it up to 10,000 feet, and we'll dive it at a target. So that's exactly what we did, and we hit 330 miles per hour on that jet at idle throttle. So we weren't even at full throttle. We probably could have hit more than 400 miles per hour, I would imagine. However, it's still an RC airplane, right? It's mostly balsa wood. When you try and pull up out of something like that, you're talking about 6, 7, 8, 9 Gs, and the potential to just kind of rip some balsa wood in half on a 100-pound airplane, right, at 300 miles per hour. So those are a lot of things that we have to consider. The structural rigidity of an RC airplane, when comparing it to a munition, is minuscule, right? So we can't do things that a munition can do. So or even a manned airplane, right? So, but we have other platforms too. We have a large 11-foot wingspan. It's almost 11.5-foot wingspan. We call it the Osprey. It's actually a target drone that the military used to just have guys go out and fly them. UH-60s would come in, or AH-64 Apaches, even C-130 gunships, and we've flown these missions. You fly them out over the ocean, and somebody comes and intercepts and shoots it down. That's always a fun day because you're generally flying from the beach. You send it out over the ocean, it disappears, and then your camera feed eventually gets cut whenever some bullets come flying through your plane. So you just pack up and go home and leave it out in the ocean. So we do have other missions that we fly where we do recover those planes. We'll fly them out about 60 plus miles out over the ocean. We'll fly a pattern for a radar, and then we'll turn around and fly it back. So 90% of that is all autonomous. So that I wouldn't consider full autonomy. I would consider minimal autonomy. It's just an autopilot flying a pattern out there, and they tell us what they want the pattern to be so they can run their radar. That's about, I would say, less than 5 minutes worth of work, and then about 4 hours of sitting on the beach, and then about 5 minutes worth of work. So those are usually pretty nice days. We also have we have other programs that we do our own vehicle development, the entire airframe developed by us. So we worked a tri-national program here recently that just wrapped up with the Germans and the Italians, and they asked us to develop a weapon, and this is an actual weapon. So we call it small scale kinetic weapon. So it's 6 inches in diameter. It is a plane. It fits into a 6-inch diameter common launch tube. And it gets ejected out of the back of a C-130 from this tube, and the wings pop out, right? So it's it fully closes up, fully collapses on itself to fit into this tube. So it does have a warhead in it, even though we don't do any of the energetics testing. We don't do any of the warhead testing. It is designed for a warhead. It is an unpowered munition, and it is a dive munition. So generally, when you talk about dropping bombs or munitions, when you try and fly a munition and you want to hit a target over here, you have to fly that munition out and around, right? So what we've done is taken basically a small UAS with a inverted VTAL, and we added an upper and lower side force generator, or stab or stabilizer, whatever you want to call them. So we have one up, one down, and of course both the wings. What that allows us to do is strafe straight side to side or up and down, right? So we actually built this thing, fully designed it in-house. We do all of our own development. We do all of our own machine work on the molds. We lay our own molds. We lay our own wings. We lay our own fuselages, the whole 9 yards, right? And we went and took this and put it in a wind tunnel and tested everything. Built everything out of carbon fiber, made sure it would handle about 10 Gs. The wing loading, it will handle about actually 12 Gs before our wings will break. And head out to the range and go fly it. So it is, even though I say unpowered, it does have a battery, it does have an engine in it. If you want to be able to call that munition off, you can, and it will last for about 10 minutes. You can fly it away and go crash it somewhere else or land it or whatever it might be. So it does not have landing gear. We put a parachute in it just because we don't like having to rebuild it every stinking time. Generally the parachute, oddly enough, due to some aerodynamic forces, the parachute door has trouble coming open unless you are under its stall speed, and then you have to kind of give it a couple of orcas, right? It's a couple of orcas, and then you can pop that parachute door open. But generally, we're gonna set it into a stabilized mode because it has again a Pixhawk flight controller, right? Pixhawk autopilot, and you just let it glide in and stabilize. Engine off, glide it in, and you can mostly save most of that plane. So again, this is an actual weapon with a Pixhawk autopilot. So I know that sounds crazy, and some of you guys might know what a Pixhawk is, some of you might not, but it's an actual weapon with a hobby autopilot. So other than that, that's about all we really do. I have we do some other stuff, right? So we do every time we fly, before we test anything, we will run every bit of what we do in a simulation first. So we do lots of modeling and simulation. We put our airplanes in wind tunnels, take our wind tunnel data, create an actual simulation model, full aerodynamically accurate model. Using different physics engines, it doesn't really matter. We use JSB Sim most of the time, but we use some other physics engines and whatnot too. But it's more or less just a visualization tool. And we will go test 100% of what we're going to do in simulation before we ever do it out on the range live. And it is the exact same autonomy that we run in simulation that we will run out on the range. We have some other programs too that that they focus more on navigation and estimation. So basically they'll take a large UAS, usually one of ours, they'll put like a giant magnetometer in it, and they'll put a couple of cameras on it and take the GPS out. And what they're trying to do is localize and navigate with no GPS. So based on terrain features and the natural magnetic poles of the Earth. So, and they do this live and issue commands from their autonomy into the autopilot, and then be able to navigate or traverse whatever kind of terrain that they feel they need to. So there's a lot of different research efforts going on. GPS denied research is one of the big ones. It's very easy to spoof GPS or deny GPS. And then cooperative systems as well. So one of my favorite things that I've ever watched was the latest, what was that, the White House Down movie, where they shoot all the drones out of the tube. There's like 100 of them out there going crazy, right? Are we at that point? No, we're nowhere close, right? Nowhere close. Could we be? Yeah, probably, but we just don't have anything that can process information that fast live, right? So if you think about it, what you're looking at with that is kind of what I'm after, right? That's kind of what we're trying to do, is launch a whole bunch of vehicles all at once and attack targets all at once, all totally autonomous, and let these vehicles go think for themselves. So no pilots. Even though we have pilots, no pilots. So I think that's really about all I have. I don't have much else, I don't think. I think some of it can be answered with some of the questions. I'm sure some folks have some questions for me.
Yeah, we're gonna have a ton of questions. So
please fire away. There's a lot. So there's a lot that when I walk into our tiny little shop, we're a team of less than 10, right? And we all come from different disciplines. And mind you, AFRL is so the breakdown at AFRL RW, 650 employees, half government, half contractor, and I think about 30 actual military. 38% of AFRL RW has PhDs. So 25% has some form of an advanced degree, a master's plus, right? And then the remaining has a bachelor's degree. And I think there's 10 total that do not have degrees. So whenever you're going through the halls over here at AFRL, especially a big dumb Army guy like myself, you almost kind of feel little, right? So because there's so many, you know, physics engineers that have been doing this for 40 years or something, you know, CS guys and whatever else that have PhDs in crazy stuff, orbital mechanics, right? One of the guys I work with has a PhD in orbital mechanics, so crazy stuff. And you almost feel like the dumb guy, you know what I mean? Even though some folks on the other end of the world would think I'm a pretty smart guy, I'm like, not around these folks. So AFRL is a very rewarding, it's an amazing place to work. I have learned a lot. I learned something new every single day. So anyways, I'm sorry, go ahead.
So one of the focuses of our students in this course is on examining unmanned system platforms, marrying them up to a specific use case, and coming up with a configuration, an optimal configuration or an acceptable configuration, really, to meet a set of given requirements or conditions. I'd like to ask you, yes, within a budget, which is very real world. And for my class,
Yes,
I gave them a budget of $75,000. The more or less the scenario is this is something you're going to pitch to a supervisor who said, you have a finite amount of time and here's $75,000. Prove it with that. And then if it's workable, we'll invest $500,000, 500,000. To me, that's a very realistic scenario.
Actually, it's very realistic. So once a year, this is outside of AFRL, so I don't want me to backtrack here, to sidetrack here, but so Torch does a competition every year, and basically it's a business pitch, and it can be anything you want. I think one year that won it was like a geofence dog collar, right? So this past year, a friend of mine won it. His small team decided they wanted to use a UAS, a quad rotor, to do 3D visualization. So basically mesh mapping, 3D mesh mapping, right? And the company decided, if you win, we're going to give you $75,000 to go actually do it. So they did, and actually $75,000, they won the 75 grand to go actually build 2 of these platforms or 3 of these platforms to do it. And if they can make it work properly in 75 grand, they're going to get $500,000 to go showcase this on a much larger scale. So your numbers there are pretty accurate, even though this is kind of side hustle thing for Torch, has nothing to do with what I do, right? Those are pretty accurate numbers. Like $75,000 sounds like a lot of money, but it gets dried up pretty quick, especially when you try and match something to a use case, right? So very good.
Given that real world condition, let me ask you, because this is going to come up in a lot of the safety considerations. How important is redundancy in your, if it is important, where do you emphasize it? In what elements of the unified UAS?
Containment. So containment is, for us, is our biggest, right? No one likes to have non-redundant systems, right? If you can have a redundant radio, that's amazing. If you can have redundant, you know, telemetry link, awesome. I mean, that's huge, right? Because if you have, everything works fine the first time. The 10th time, everything works perfect in simulation, everything works perfect in hardware in the loop. And as soon as you go throw that plane on the range, take it off from a runway, whatever it might be, you have some form of a problem. Sorry, my phone was ringing. I've seen it all, right? So the very first time we flew this foam plane, an ESC just said, no, not today. So we were down an engine, right? And this is the first time we've ever flown it. We were manually flying it. And when you're twin engine like that, you start to create a lot of torque in one direction. On a high windy day, we wound up inverted and into the ground. So, and that causes problems for us, right? So, yeah, things happen. And if you can have redundant systems, I mean, you got to have them, right? If you can, I would always say do it. So your data link is one. Most importantly is your containment. So what you don't want to happen is this thing to go fly somewhere, whatever the platform is. You don't want it to fly off, right? Because it could potentially hurt somebody, impact, especially around here. We have a lot of like beach helicopter tours. We have a small Destin airport that flies a ton of Cessna 172s, 182s, private planes, right, up and down the beaches here. You have 2 or 3 schools here, I want to say, pilot schools. So the last thing that we want is to lose that airframe and have it fly who knows where, right? So containment for us is the biggest. And the autopilot has its own containment. But what happens if your autopilot goes out, right? It's still a hobby autopilot. No matter how great we have, data on this thing, it's still a hobby autopilot, and things still happen, right? Or if you lose a cell in your battery, right? Something, you never know. You're not on board to control it. So if you lose that link, if you lose your autopilot, you don't know where this is going to go. Somebody could get hurt, worse, killed, right? Even from one of our styrofoam, igloo coolers flying around, someone could still get severely hurt by that. So yeah, if I said any one thing to have a redundant system, it would be containment. If you can find a way to contain it, a second autopilot even that runs by itself, that would work too. Or something like what we use as the bounder. So
you mentioned ESC. Do you power your onboard servos and your other control mechanisms? Do you use the primary battery through the ESC as like an accessory out to power that, or does it have its own dedicated power source so that if you lose the main battery or lose the ESC, you still have power available?
So that's a good question, and it depends on the configuration, right? So one of our biggest things is configuration control. And anytime, especially when you start up a new program, you have your outline of your configuration. You've decided what plane you want to use, what components you're going to use, and then things happen, right? Like you lose an ESC, and then safety says, "Hey, find something else." So we change ESCs, we update our configuration control. We actually take our entire plane and we build our entire plane on a 3/4 inch piece of plywood. No fuselage. The entire plane is on a piece of plywood. So we call it an Iron Bird, right? I'm sure some folks have heard about an Iron Bird, right? Totally laid out. Everything works. I mean, we can fully run our autonomy on our Iron Bird with no fuselage, right? But what that allows us to do is poke around and test things without having to change it in a plane, right? Because every time you unplug something and plug it back in, you're wearing it out every single time, right? It seems like you could go through 10,000 of that right there in a day sometimes, right? So we do it on an Iron Bird first. That way, when something breaks, I'm not having to tear apart a plane. ESCs, and this is sometimes we have our own development board that power will run through with a separate battery that powers our ESCs. Sometimes we use ESC BEC out power, which is what we're doing right now, to power our servo rail on the Pixhawk. Sometimes we'll use a separate BEC with its own power source to power our servos.
Real quick for the folks that are kind of hearing alphabet soup here, that's electronic speed control with battery elimination circuitry.
Yes, sorry. So yeah, a lot of new, especially Hobbywing has these great programmable electronic speed controllers that have an elimination out circuit, right? So elimination circuit out, and it also programmable. So, and then Mach also with their power supply, you can buy those at I think four position out. Generally, it's going to be Pixhawk Power 1, Pixhawk Power 2, or Autopilot Power 1, Power 2, and then the next 2 outs are configurable up to I think 14 volts on a 10 amp rail. And if you lose that rail, you don't necessarily lose the others, right? So we have done like a 5.5 or 6 volt out and power our servos with that before. Oddly enough, we found an interesting. Sorry, my kids are being crazy. I've got a 2-year-old and a 4-year-old. So yeah, so oddly enough, powering through the Mach, we have found an odd noise at about 14 kilohertz that will make our voltage on our servos jump from 6 volts to upwards of almost 14 at times. And obviously you've got to put an oscilloscope on it to be able to see that, but we have found odd things like that. So again, how do we fix that? We have everything on an Iron Bird and can find it there first, come up with a change, document it in our configuration control, make said change. Once we know it works on the Ironbird, we'll change all the planes. So yeah, odd ways of powering servos, but it depends on what your plane is capable of doing. If you have a tiny little plane or tiny little quad, you may not have that option, right? If you have a large plane, like our jet comes, I think, 55 pounds. We build it out to about 105 pounds. We can put almost anything we want in it. So Osprey's the same way. We can put almost anything we want. If we want to do some giant power supply for whatever it might be, or some new test radio, we can. We don't have to worry about weight, just CG.
So I'm going to ask a totally left field question here and then I'll turn it over to the students. But this is something that we try to get from all our guest SMEs that come in, because it's something that in our field, it's so imperative. What tools or resources do you personally use to stay informed? And what are some of the challenges of sifting through all the available material that's out there?
So I'm a supervisor of 15 people, and I have obviously what you guys just saw, a 2-year-old and a 4-year-old running through here. And I'm currently in a 900 square foot tiny little house. So I don't have a lot of time or space to keep up. However, part of my job is research and development, science and technology. I need to stay on top of what's out there. So the big UAS symposium in Atlanta every year, which one is that? We were supposed to be there last year.
AUVSI Exponential.
AUVSI Exponential.
So it does rotate this year, this summer, coming up in April. It's here in Orlando. Please consider coming.
It's in April in Orlando. I will more than likely be there. So due to COVID and some of the restrictions, and then the Delta variant and how all that stuff happened, we were supposed to be there. I probably would have seen you there in Atlanta, but of course, yeah, that happened. So we got cannexed on that. But yeah, so those AUVSI is a huge proponent for us to pull research, find other vendors, people doing different types of research. And then, IEEE is always good. Just reading, Googling, keeping up with the industry, doing things like this, right? Reaching out, taking some time to reach out or at least respond to an old professor and sit in his class is huge to see what else is really going on in the industry. So you take a little bit of time, a little personal time to do some Google searches, and usually you'll find some great stuff out there. So
with that, I'm gonna turn it over. Oh, yep, David.
I was just going to say, when he said old, he was referring to you.
I'm not a spring chicken myself, gents.
I'll take the hit. All right. Well, class, anyone have any questions for Ryan? If you do, use the hand raise icon and I'll call on you. Okay. So you didn't use you didn't put your name on there, so I'm assuming that is that Jose?
Yeah, that's Jose de la Cruz. I
Okay.
am so sorry that I'm using my iPhone. I was surprised when I saw that. So Ryan, I got a question. You were talking about the C-130 deploying some of the drones from the back. Are you talking about the Gremlin program with DARPA?
I'm vaguely familiar with Gremlin, but no, I am not talking about Gremlin. So we've done some stuff with, so DARPA I think was one of the proponents of, and don't quote me on this, right? So I think DARPA was one of the proponents of the CLT. And and I know SOF got involved in that, and they wanted to be able to launch vehicles out of the back of the C-130, and the CLT was kind of the way to do that. And I believe Gremlin is a multi-launch system.
Correct.
So I don't know a whole lot about it. Some people wrote me in and asked me questions about things like that sometimes, and I'm like, I don't know,
Oh, okay.
So,
no, yeah, because
yeah.
I'm sorry about that. I heard you talked about the ones that deployed from the C-130, and I'm like, because lately here, I work on the C-130 myself. I'm in the manufacturing line, and we were talking about that because we got a few programs coming in, and we were thinking that was going to be one of the programs. However, that's with DARPA. They're the ones handling that, and then the program is, like you say, multiple Gremlins coming out of the aircraft. Yeah, That was what I was asking.
Yeah, so yeah, I'm not hugely familiar with Gremlin, but yeah, C-130, I mean, it could be just about anything, right? So, but mostly CLT was designed for C-130. CLT is Common Launch Tube, and it deploys some form of aircraft. So one of the interesting things that you guys can actually Google is, I think it's L3. L3's Coyote, or I'm sorry, Raytheon. Raytheon's Coyote Block 2. In fact, their Coyote UAV period, they have Block 1, Block 2, and Block 3. It is a CLT deployed UAV, right, or UAS.
Awesome.
So that's probably the most notable one. And they did some stuff for us for a couple of years on a program called LCCM, it was Low Cost Cruise Missile, and that's kind of where the Coyote really was developed as a CLT launch type vehicle. So kind of cool. Yeah, I don't know a lot about Gremlin, but yeah, that's kind of where the world's going, right? Is how do we take a whole bunch of these at one place and dump them all out at once, and then what do they do once they're in the air without a pilot, right?
Well, the Gremlins, I know that they collect data and bring it back to the aircraft, and we get some of the information out of it. It's kind of like like mapping, I guess.
Yep, there's a telemetry stream that goes from the onboard system in the C-130 to that you can actually control the airframe from the plane. And then there's some other stuff too that we're working on where you've got that data link, and then you also have a data link to an operator on the ground, and that you can do a handover. So they'll launch them and then hand them over to some soft guys on the ground. So I don't know when that is going to take place, but there's some testing on some equipment to do that right now. So I might get involved in some of that. I don't know. We'll see. I might get pulled into it inadvertently.
And I'm going to send you all links on a bunch of this stuff, just so you're aware. There are multiple iterations and programs that have tube launched platforms out of C-130s and other large aircraft. The Altius. There's another program that was an R&D program a couple of years ago out of Wright Pat up in Air Force AFRL that was also focused on something similar to the Gremlin. So I'll put all this stuff, including some of the other stuff that we've talked about with Ryan, into an email out to you all, so that you can, if you want to explore any of this, you'll
Thank you.
access.
For anyone curious, Wright Pat is actually my headquarters, right? So Wright Patterson in Ohio is AFRL headquarters. So we're just a branch of AFRL, basically out of Wright Pat, but we're down here at Eglin. So
outstanding. All right, Robert, you have your hand up next.
So as doctrine has been shifting towards engagements with near peer adversaries rather than places where we have total air superiority, have you guys been working on any projects for counteracting area denial spaces, or any type of delivery systems capable of delivering supplies to troops, or any type of payload that's non-munitions related?
yeah, great question. So the air superiority piece or aerial denial piece is kind of always in the back of our mind, right? So, and that's kind of where the swarming vehicles kind of comes from, right? But then your second question there, on the non-munitions related, yes, we have actually done something on an aerial delivery. Interestingly enough, we call it Commander's Challenge. Once a year, AFRL gives a couple $100,000 out to some groups that apply to compete in some local challenge. And we won it a couple of years ago using what we called the Havoc. So Havoc was a twin rotor helicopter built on basically an old Harley. I don't want to say chassis, but close to, right? About the size of a Harley. And I actually had an 84 Harley gas tank on it. Anyways, this large helicopter would carry a 50-pound drum that then gets released. It gets flown into wherever hypothetically and then released. And then that drum then has to control itself down and use some form of GPS to get it there, right? So what we did was a unpropelled drop system, if you will, basically a quad rotor, but no motors. So the arms would kind of pop out. They would auto gyrate, right? They would self rotate, and then we would use the collective on like a helicopter, we would use collective on each of those arms to control the airspeed of it down and the direction of travel. We dropped a bunch of them, and I can't say that we were very successful with many of them, but we dropped a bunch from a Huey. And I think we had one or two that lasted a few seconds. But basically, we would have needed a couple $100,000 to improve the system. But in theory, I think it would have worked pretty well. We had one or two of them that started to work pretty well, but then the actual forces of 7,000 or 8,000 RPM on those hobby grade props and prop holders that we were using would just shuck right off, right? So yeah, so there's definitely research and being done on some of those other problem sets, right? How do you deliver something to someone way out in the middle of nowhere, right? Other than fly a tiny Sherpa through the mountains and, kick a kicker box out that's got tarps for a parachute. And I know that because I've been there, right? Like watched it many of times, combat resupplies many of times. So how do you do that more safe and without putting people in danger, right? So yeah, those good question. Yeah, but those definitely taking place.
Excellent. Marjorie?
Hi. The question I have is, you were talking about the Osprey and how you can get it to like 100 some pounds. Is that it, like fully outfitted, or are you able to add even more weight to that?
So what we describe as an Osprey may be different than what you're thinking of as an Osprey, right? So what we call Osprey is an older target drone developed several years ago, comes with a Piccolo autopilot. We still fly Piccolo in it just because we buy them that way, but we more or less use that vehicle as kind of a truck. And what I mean by truck is it doesn't necessarily have a sole purpose. We have a bunch of them, so we can outfit them with different things. When somebody comes to us and says, hey, we want to collect data at this altitude, at this airspeed, or whatever it might be, we can outfit our truck UAV with that, right? And we have had it up to about 94 pounds, and we have had to reinforce the tail and the spars. We have crashed those planes before and totally rebuilt them, but yeah, I mean, essentially it's just a target drone that we use as something we can add pounds of payload into. So in the UAV world or UAS world, you don't really hear such things as pounds of payload. That's a lot, especially 10 or 20 pounds of payload. That's a tremendous amount. So, but a big plane will do it. So if you want to fly long, fly far, how do you hold that much fuel? A big plane, right? So.
Is it a twin boom pusher?
Yes.
Okay. Yeah.
Yep.
Every time we talk
Looks like
about
a tiny
something,
shadow.
Yep. I'm trying to grab websites of them so I can share that out. So
yep,
I'll make sure to share this out.
Yeah, it's a really cool airplane. So we've actually at like 8,000 feet and about 4 miles out. Don't ask me how our pilots saw it, but our two pilots can see that far, eagle eyes. They're orange, so it helps. And I have zero depth perception at those kinds of distances. So somebody saw it, had an engine out at 8,000 feet AGL and 4 miles out, and they safely landed it.
Outstanding.
Pretty impressive.
Well, does anybody else have any questions? Because I definitely have a follow-up question I can push if anybody else doesn't. Robert, you have another question? Nope. Okay.
Nope,
well,
I do.
Go for it.
So the big thing as UAS systems are being developed is counter UAS. Have you guys been working with anything to either counter UAS or counter, interference weapons to prevent interference with UAS?
Yeah, so another good question. So we don't do a lot of counter UAS. Now we do some like some green on, well, some red on blue, right? So swarm v swarm is what we'll call it. We do a little bit of stuff in simulation with that, and that kind of plays into some other programs. I don't do a lot of counter UAS. DARPA, I know, does a lot of counter UAS. Mr. 30 Acre can probably talk a little bit about that, but we do a little bit of the swarm B swarm talk there. What was the second part of that?
It's kind of redundant, do any counter UAS things? Like, are
Yeah,
you even
yes.
developing any systems to protect your systems?
Yeah, absolutely. So we look at a lot of things like anti-jam. It's huge, right? Anti-jam, frequency hopping in our telemetry links helps. Generally, that's what you're looking for, right? It's going to be in your telemetry link or your intra-swarm link, right? So your planes talking to each other. And we will work closely with folks like Persistent Systems that are really in the market of developing a system of systems that can do those things, or Trellisware. Silvis is another big one that do those types of data links, those comm links with anti-jam type, anti-interference type development. So we're not going to do a lot of that. We're not necessarily in the market for that, but we will work with those other folks to combat those issues and then go fly and test them and jam our system at the same time, knowing that we're going to lose our link, but we want their radios to be able to control themselves and combat some of that anti-jamming. Yeah, so the counter to counter UAS, yes. Yeah, we do a little bit of that, but most of it, again, it's on the telemetry link side, and we let the experts at the radio places develop that stuff. So David, did you want to talk a little bit about counter UAS?
Yeah, so Robert, here at DARPA, we do a lot of counter, right? It's the counter joint task force office. That is a huge thing. With you being in uniform, you're well aware of the problems going on with those right now. There are multiple programs that are running around trying to figure out how to do them, whether it be kinetically or non-kinetically. And I could talk for an hour on a couple of programs we just finished. But there is a new emerging technology that we're looking at here at DARPA, and that is how to do the counter UAS, right? Because our near peers are doing the same things. They're trying to figure out how to not only take ours out, but protect themselves. So that is an emerging technology that programs are just starting to look at how they can do that. And Ryan's right. Most of it comes back to, can you protect the radio link so that if the radio link gets jammed, the aircraft can still execute its mission as it was pre-programmed before, which seems simplistic, but once it gets jammed and once someone gets into it and starts spoofing it from a GPS part, you now got to work in a GPS denied environment, plus you're working in a jammed environment, and somehow you have to have told the system how to semi-autonomously get to a point, execute its mission, and get back home while not knowing where the return point's going to be because of where its mission sets at. So it is definitely a problem. And I'll echo what Ryan said a minute ago. I am the dumbest guy that works here at DARPA. The guys who are here just blow my mind when they start talking and thinking through things. But it is definitely one of those sets that is really starting to take off now.
Yeah, so to caveat on that, when that does happen, right? So if you have a link that gets jammed, GPS spoofing, whatever that might be, and you wind up in a denied environment. So that's what we look at, right? That's what we're researching. They can't jam us and they can't spoof our GPS if we don't have it, and we can navigate, localize, prosecute targets, etc., without it anyways. So that's where I come in, right? That's the kind of research that we really look at.
Yeah, same thing. We're doing the same thing. We work a lot with AFRL. It's a whole tie-in of how do you do vision mapping, right? Of how you're going to use the actual sensors that you have on board to know where it's at as it's flying across the ground. And we look at this also for UGVs and UUVs and USVs as well. Everyone seems to talk about it from an aerial perspective, but all four of the domains are impacted with this.
Outstanding. See, this is what happens when we are able to bring together, so many perspectives. And I don't know if any of you noticed when we first came on, David Warden and Ryan were talking about just some commonality and some shared experiences in this space. That is something that you will see a lot as you begin to work in this field. Is there somebody always knows somebody, or there's always some kind of overlap in experience that is complementary and allows you to build bridges. So that's something to me that's really exciting. Kind of on that note, I'd like to ask Ryan and David, both of you really, because you're both in field. What specific guidance do you have for those students that are looking to enter this field? What are some specific knowledge areas, skills, abilities that you see that would help support their versatility and employability?
Yeah, so I kind of have 1.5, and we've talked about this before. I think the biggest downfall of the ERAU Unmanned Systems program is code. There is 0 code in the program. So I will say that I shouldn't say it hurt me because I actually just learned it myself, right? So, and I'm no CS guy, right? But I mean, I can go pull up anybody's code. Everything I use is Linux anyway, so I can look at anybody's code, tune an autopilot, right? I can go into the autopilot's code, not use their actual GUI, and tune an autopilot. And it took me some time to learn that, and that was the one thing I wish that Embry-Riddle did teach in this program, was a little bit of like Python, C++. So on the other end of that, I think one of the things I had to teach myself that I use a lot is actually AutoCAD. So I have access to, I don't know, I think I have, in fact, I have stuff running on a printer right now, right? So I have multiple, 7 3D printers. So, and then we also have a full machine shop, right? When I say a full machine shop, I have a lathe, I have a Fadal 3-axis CNC, and I have 1 machinist. So I have a ShopBot 4 by 8 foot by 8 inch Z-axis router table. So I have to CAD things, brackets, mounts, whatever it might be, either 3D print them or run them in the ShopBot, or molds, making molds for wings, for noses, for parts, whatever it might be, for entire tails. I don't know, whatever it might be. I had to learn how to use AutoCAD. That was the one thing that I wish I had gotten from either my undergraduate or my graduate, and I did not get either. Even SolidWorks would be great, but so we use Autodesk, but SolidWorks would be fine too. Just having that knowledge base would be great. I would recommend it to just about anybody. And on the CAD side of the house, in fact, both sides of that, right? The programming part and the CAD side is free. You can go look just about anywhere and have free courses out there that will, you can learn Python, C++, C, C++, C#, and you can download Fusion 360 for a year for free. And I think you can continue with it if you're a student. They'll give it to you for free. So highly recommend Fusion 360. I hated it when they first came out with it. It's great now. They're still making improvements on it. And then if anybody wanted some additional stuff for C++, more or less like robotics type engineering, coding, I can recommend some things there too.
Outstanding. And I will share with you, since you finished the program, that was what, 2018. 2018, 2019, we onboarded a new option, the Master of Science in Unmanned and Autonomous Systems Engineering. Now, we don't cover coding in it, but coding is an incorporated feature, meaning the students that are in that come in with prior coding experience. So when they are developing prototypes and conceptual demonstration, they can rely on those that already existing skill set. But I do absolutely agree that it's something that we as a organization need to look at, is how can we help build those practical real world skills, especially as we do see a lot of folks out in industry are they're not necessarily putting people into clean cut jobs. It's very amorphous. You're going to have a lot of responsibilities outside of what is typically associated with this role. So having that wide variety of experience in drafting in AutoCAD, as well as 3D print or other additive layer manufacturing, understanding how to debug, develop, fine tune, and compile code, extremely beneficial. And even if it's just scripting, like you mentioned, Python, which is a derivation of C#, there's inherent value to that. And that is something that I can tell you from my perspective as the program coordinator, we're looking at what are different certifications that are important to students in the unmanned system field, so that if we do not offer them, is there an option, is there a bridge that we can help to build so that they can pursue that and achieve ultimately the success that they want. So I'd like to also ask that to David, you know, in your sector, in your side, in the DARPA R&D area, you know, what are...
So from my background, not only in the R&D world, but having lived in the operators world, right? I echo what both Ryan and Brent are saying as far as the coding piece, because me personally, when I first got into a point where there was coding to be done, I was an old dog on a porch and was getting my rear end whipped because I had no idea what I was doing, right? But there's other disciplines that you really need to dive on. If you find yourself as a UAS ops guy, you should be able to pull into the propulsion. You should be able to pull into the avionics. You should be able to pull into the airframe, how to do the composite repair. You should be able to pull on just general knowledge of how to utilize, I'm drawing a blank, the autopilot system. What's it called, Ryan? Not flight aware.
The ground station. So you're going to talk, you're saying mission planner, Q ground control.
Yeah, already pilot, mission planner, right?
Already pilot.
So,
yep. Or the PX4 stuff. Yeah.
But just having that flexible ability to be strong in one area and then still be able to pull out of your toolbox and help out the rest of the team, because Brent pulled on this. Unmanned systems are anything but unmanned, but it is a small team of individuals who are working together. And so because it is such a small cohesive team that normally goes out and starts traveling and operating together, not only do you know what to order each other for dinner because you're traveling all the time together, but you get to the point where you know who's going to be able to fix what, when, and how to jump across it. And you know if someone's sick, how you need to fill in. So it is that cross-pollination across the entire team of being able to backfill each other. Those are the little other pieces. Now, from a hiring manager, I will tell you the first thing that I do when I look at a resume is I look for clean, concise, and what is being laid out in a logical format for your hiring managers to review. So that's just a little side note. As you go through the university, you'll get assistance as you start doing employment stuff. But if you're starting to put resumes and stuff together, make them clean.
Yeah, my guidance on the looking career development, career pursuit, versatility, and clearly communicating your willingness to learn. You don't always have to bring all of it to the job as far as the knowledge set or the experience. Some of it is on the job training that they are more than happy to help you with. They'll pair you with an experienced person in that to help you develop new, or really their way of doing things. And that's, you know, that's common across the board in corporate cultures. And it's just, like I said, the ability to be willing to learn and communicating that out is an essential trait. Well, really, I want to thank all of you for joining us this evening, as well as a big thank you to Ryan and David. Remember, to receive credit for this, for participation this week, you need to develop just a brief overview for assignment 3.3. It's got to have just a mention or a discussion of how our guest organization uses UNSY technology, how lessons learned or observations made by our guests can help make new enterprise more viable. And then really any new information you're not previously familiar with, you know, how your overall understanding of the topic has improved. For my class, I will tell you, I don't need references in this. In fact, I'm going to be sending you a whole slew of materials just to look over that connected to our discussion. If you want to incorporate those, fine. This is very casual. This is more mirroring the type of interchange and exchange you would expect to see in the field or in industry. Combined with, if we were in a brick and mortar classroom, the type of discussion and back and forth we would have. So I really want to just more or less incentivize you to come out to these sessions and realize, you know, there's inherent benefit. This is going to be the first of 3 this term. We're going to have one every 3 weeks, and I really hope to see you and some of our classmates maybe that couldn't make it. Hopefully they'll be able to make it to future ones. So with that, I hope everybody has a great evening, and thank you again for joining us.
Good night, guys.
Thank
See
you very
around.
much.
Thanks, Brent. Thanks, everybody.
Thank you, Ryan.